esteemed faculty members, researchers, and dear participants. Myself, Ranjana Ray, faculty member of Electronics and Communication Engineering Department. I welcome you all to the International Conference on Advances in Communication, Medical Electronics, and Smart Grid Automation, Acmesga 2K26. Which is organized by Department of Electronics and Communication Engineering, Electrical Engineering, and Department of Biomedical Engineering. This conference brings together brilliant minds from academia, industry, and research to exchange ideas, present innovations, and explore emerging trends in these transformative domains. In today's rapidly evolving technological landscape, advances in communication systems, medical electronics, and smart grid automation are playing a pivotal role in shaping a smarter and more sustainable future. Acmesga 2K26 serves as a platform to foster collaboration, encourage interdisciplinary research, and address real-world challenges through innovative solutions. We are truly honored to have with us our esteemed dignitaries. I would like to request to kindly come forward and grace the dais. First of all, our Honorable Conference General Chair and Chief Guest, Professor Dr. Vidyadhar Subudhi, Director, NIT Warangal, whose presence adds immense value and prestige to this occasion. Please, sir. Our distinguished guest of honor, Professor Dr. Tapas Chakraborty, Honorable Vice Chancellor, Maulana Abul Kalam Azad, University of Technology, West Bengal. Our guest of honor, Padma Shri, Professor Dr. Ajay Rai sir, will be joining us soon. Our guest of honor, Dr. Trupti Ranjan Lenka sir, who is Associate Professor and in NIT Shilchar. Our respected conference program chair, Principal Sir, Professor Dr. Partho Sarkar sir, whose visionary leadership continues to guide our institute towards excellence. Please, sir. Sir. Dean Academics, JAS College of Engineering, Dr. Shomabruta Sahasar, is requested to sit on the dais. Now, our respected General Secretary, Dr. Indranath Sarkar, Professor, Electronics and Communication Engineering Department. Convener of this conference, Dr. Alok Kumar Srivastava sir, Head of the Department, Electrical Engineering. Co-convener of this conference, Dr. Karubi Ganguly, Head of the Department, Biomedical Engineering Department. Co-convener, Dr. Momita Pal, Head of the Department of Electronics and Communication Engineering Department. Please, ma'am. JIS College of Engineering has always been committed to excellence in education, research and innovation. Through initiatives like Acmesga 2K26, we aim to create a vibrant platform for knowledge sharing and academic excellence. This conference features keynote sessions, technical paper presentations, and expert discussions covering cutting-edge developments in communication technologies, healthcare electronics, and smart energy systems. We are delighted to receive contributions from researchers across the globe. We express our sincere gratitude to all speakers, authors, reviewers, and participants for their valuable contributions and support. Once again, I extend a warm welcome to all of you and wish the conference grand success. We will now proceed to the curtain raiser session. It is my privilege to invite Dr. Momita Palnam, Joint Convener, Acmesga 2K26 and HOD EC Department to kindly deliver the curtain raiser address. Please.
Good morning, distinguished guests, esteemed dignitaries, respected faculty members, researcher, industry experts, and my dear students, and the paper presenters for Acmesga 2K26. It is my great privilege and honor to welcome you all to the second international conference on advances in communication, medical electronics, and smart grid automation, Acmesga 2K26, hosted by JIS College of Engineering in association with three departments: Biomedical Engineering, Electrical Engineering, and Electronics and Communication Engineering Department. Today, as we gather here, we are not just inaugurating a conference, we are opening a gateway to innovation, collaboration, and transformative ideas that have the potential to shape the future of technology and society. Acmesga 2K26 stands as a vibrant platform that brings together brilliant minds from across the globe. It integrates three of the most impactful and rapidly evolving domains: communication technology, medical electronics, and grid automation. Those are not only the advancing in engineering field, but also redefining the human life. In an era driven by digital transformation, seamless communication systems are the backbone of connectivity. At JIS College of Engineering, we strongly believe that knowledge grows when shared. This conference embodies that spirit, providing a global forum of academicians, researchers, industry professionals, and young innovators to exchange ideas, present cutting-edge research, and foster meaningful collaboration. Over the next 2 days, Acmesga 2K26 will witness insightful keynote address, technical session, JIS College of Engineering, we strongly believe that knowledge grows when shared. This conference embodies that spirit, providing a global forum of academicians, researchers, industry professionals, and young innovators to exchange ideas, present cutting-edge research, and foster meaningful collaboration. Over the next 2 days, we will witness insightful keynote address, technical session, and discussions led by eminent experts. These interactions will not only enrich our understanding, but also inspire us to think beyond conventional boundaries. I'd like to take the opportunity to express our heartfelt gratitude to our distinguished guests, keynote speaker, participants for being a part of this prestigious event. Your presence adds immense value and prestige to this conference. To our young researchers and students, this is your platform. Engage, question, learn, and innovate. As we raise the curtain on Acmesga 2K26, let us embark on this intellectual journey with curiosity, collaboration, and commitment to excellence. With this, I officially mark the curtain raising of the conference. Wish you all a highly productive and enriching experience. Thank you.
Thank you, ma'am, for your insightful and inspiring address. Let us begin this program by seeking the blessings of Goddess Saraswati, the embodiment of knowledge and wisdom. May I now invite Mrs. Sumana Banerjee, faculty member of Biomedical Engineering Department, to grace the stage with the Saraswati Vandana. All of the participants, please stand.
भारत में भर दे
Thank you, ma'am, for that beautiful and soulful rendition of Saraswati Vandana. May I request our chief guest, guest of honor, and other dignitaries on the dais to kindly come forward for the ceremonial lighting of the lamp. With the lighting of the lamp, we have invoked knowledge, wisdom, and positivity for today's event. Professor Dr. Partha Sarkar, Principal, JS College of Engineering and Conference Program Chair, Acmesga 2K26 to deliver the welcome address and inaugural speech. Please, sir.
Very good morning to all present in this auditorium. Respected Chief Guest, Professor Dr. Vidyadhar Subudhi, Director NIT Warangal, respected our Honorable VC Macau, Professor Tapas Chakraborty, respected Padma Shri Ajay Kumar Rai, respected Dr. Trupti Lanka from NIT Silchar, my colleagues, Dean Dr. Shomavat, Dean Academic Dr. Shomavat Shah, Professor Indranath Sarkar, Dr. Alok Srivastav, Head of the Department Electrical Engineering, Dr. Paravi Ganguly, Head of the Department Biomedical Engineering, and Dr. Momita Pal, Head of the Department Electronics and Communication Engineering. Other dignitaries of the dais, other HOD of the departments, of various departments of my college, researchers, academicians from other institutes, and my dear students. It gives me immense pleasure and pride to welcome you all to this international conference, Acmesga 2K26, hosted by 3 departments of our college. The gathering stands as a testament to our shared commitment to advance knowledge, fostering innovation, and building meaningful collaboration across discipline and borders. At JSC College of Engineering, we believe that education beyond classroom only gives the proper shape to a student's future. We believe in R&D culture. We believe in our students' participations in different hackathons and technical symposium, where we want to see that our students are growing both in knowledge and skills. This conference aims to create a dynamic forum for intellectual exchange, where participants can present their research, engage in insightful discussions, and explore opportunities for collaboration. I am confident that the technical sessions, keynote addresses, and panel discussions planned over the time for next 2 days of this event will inspire new ideas and contribute significantly to our to your respective fields. Let me tell you, sir, here one or two lines about the insightful progress of this college. Sir, this college till now we have produced more than 550 patents as on date. We made it last year more than 200 publications in Scopus publication, from where we want to mean that we believe in a culture where both education and R&D are in parallel. I'd like to express my heartfelt gratitude to our distinguished keynote speakers and experts who have graciously accepted our invitation to share their knowledge and insights. I truly believe that all these things that we are doing over here for next 2 days will provide enough knowledge and knowledge sharing platforms for all those who are present here. Everybody's presence is important to us and important for all. I sincerely thank Professor Subhuti sir, who have taken all the pain to come down to this conference for our college. When I approached him, he never said a negative thing. He said, yes, I will be there. That is the kind of thing, sir, we are really, really thankful to you, sir, who have taken this much of pain to come down over here. Professor Lenka, who also didn't hesitate a single moment and accepted our invitation, and he is gracing the occasion today. We are unfortunate that two of our foreign delegates, those who are supposed to come, one from China and another from Indonesia, they could not make it today, present over here, because of the visas issues. But they have said they will present on online for their talks and all. I also extend my sincere appreciation to the organizing committee, faculty members, student volunteers, and all those who have worked tirelessly to make this event possible. Your dedication and hard work are truly commendable. To all participants, I encourage you to make this most of the opportunity, engage activity, network meaningfully, and take back valuable knowledge and experience that will shape your future endeavors. Once again, I welcome you all to this Acmesga 2K26. I wish this conference to be a great success and hope that it will be productive and memorable. Thank you, and I wish you all of you an enriching conference. Thank you again.
for your valuable words and perspectives. We will now proceed with the felicitation of our esteemed guests. May I request our principal to kindly join us for the felicitation of the Conference General Chair and Chief Guest, Professor Dr. Vidyadhar Subudhi, Director, National Institute of Technology, Warangal. Please, sir. May I request our guest of honor, Professor Dr. Tapas Chakravarti, Honorable Vice Chancellor of Maulana Abul Kalam Azad University of Technology, to come forward. Once again, I would like to request our Principal Sir to felicitate our honored guest. Thank you, sir. It is now time to felicitate our distinguished guest of honor, Padma Shri Professor Dr. Ajay Kumar Roy, Director, GIS Institute of Advanced Studies and Research and former Director, as a token of our respect and gratitude. May I request our Principal Sir to kindly do the honors. As a gesture of our appreciation, we will now felicitate our esteemed guest of honor, Dr. Trupti Ranjan Lenka, Associate Professor in the Department of Electronics and Communication Engineering at National Institute of Technology, Shilchar. May I request our Principal Sir to do the honors. May I request our respected Registrar, Dr. Devashi Shanti, to kindly felicitate our Honorable Program Chair of Conference, Dr. Partho Sarkar sir. May I request our Acmesga 2K26 General Secretary of the Conference, Professor Dr. Indranath Sarkar, to kindly felicitate our Honorable Dean Academics, Dr. Shomabrata Saha. invite Dr. Dipendu Mondol, Joint Secretary of the Conference, to felicitate our Secretary, Dr. Indranath Sarkar, Professor, ECE Department. I would like to invite Mrs. Devuthuti Upadhyay, Joint Secretary of the Conference, to felicitate our convener, Dr. Alok Kumar Srivastav, HOD, Electrical Department. Dr. Dipendu Mondol, Faculty Member of Biomedical Engineering Department, is requested to kindly felicitate Joint Convener of the Conference, Dr. Gauravi Ganguly, HOD, BME Department. Mrs. Devuthuti Upadhyay, Faculty Member of Electrical Engineering Department, is requested to kindly felicitate Joint Convener of the Conference, Dr. Momita Pal, HOD, ECE Department. May I now request the convener of the conference, Dr. Alok Srivastava sir, to kindly share a few words.
Good morning and warm welcome to our esteemed dignitaries, respected principal sir, Dean Academics, Registrar, and all HOD, distinguished guests, and my dear students. I welcome you again in our Acmesga 2K26. This is our second edition. Last year we have organized our first editions, and this year we are expanded from our first editions. Last year we have received papers around 130, out of which 65 are selected, and this year we have received paper 196 across 14 states from our country, and out of which 72 papers are finally shortlisted for our CRC press publications. So I welcome you all, our participants, our presenters and authors, distinguished authors from all different states, those who are present here and those who are on the present over online sessions. So thank you everyone for these 2 days sessions. Thank you.
Thank you, sir, for the wonderful address. I humbly request our Honorable General Secretary of the Conference to address the gathering with a few words.
Good morning, chief guests, dignitaries on the dais, off the dais, principal sir, deans, all HODs, all administrative position heads, participants, and dear students. It gives me immense pleasure on behalf of the organizing committee to present a brief overview of the paper submissions for this prestigious conference. This year we have received a total of 190 research paper submissions, out of which 72 selected for this conference presentations based on peer review, AI and similarity report. This reflects a vibrant and enthusiastic response from the academic and research community. Out of these, an overwhelming 90% of the contributions are from India, while we are also proud to host around 10% of foreign submissions, marking the global recognition of this conference. A significant highlight is the strong participation from West Bengal, which is around 42% of the total submission. This clearly demonstrates the region's active involvement in research and innovation. At the same time, we have received valuable contributions from other parts of the country, including Tamil Nadu, Assam, Telangana, Andhra Pradesh, and other states, showcasing a truly pan-Indian nature of this conference. The diversity of submissions reflects a rich blend of ideas across domains, particularly in emerging areas such as artificial intelligence, machine learning, smart systems, and interdisciplinary technologies. We are also delighted to see the participation from students, academicians, and industry researchers, making this platform inclusive and dynamic. I would like to express my sincere gratitude to all the authors for their valuable contributions, the reviewers for their diligent effort, and the organizing team for their dedication in making this event possible. Thank you all.
Thank you, sir, for your insightful address. It is a great honor and privilege to introduce our esteemed guest of honor, Professor Dr. Tapas Chakraborty, Honorable Vice Chancellor, Maulana Abul Kalam Azad, University of Technology, West Bengal. Professor Chakraborty is a distinguished academician and an accomplished leader in the field of atmospheric chemistry and molecular spectroscopy, with extensive experience in teaching, research, academic administration. He has made significant contributions to advancing technical education and fostering innovation. Under his visionary leadership, Maulana Abul Kalam Azad University of Technology continues to strengthen its focus on industry-oriented education, research excellence, and global collaborations. May I now request Professor Chakraborty to kindly address the gathering. Please, sir.
Honorable Padma Shri Professor Ajay Kumar Raj, the chief guest of this today's program, and these other dignitaries. Well, I am happy that I have been invited here to this important conference. It involves a very broad area, hence electronics and engineering, electrical engineering. Now, only words that I'd like to say here is that we in India, we are proud that we are the most populous country in this planet. We have lots of responsibility to the society, and the topics of this conference, it can only address the large problems that we encounter. With this electronics communication and this biomedical engineering, being that this most populous country, that this healthcare, it is a very important area. We all know that almost 80% of the sophisticated equipment we import from these other parts of the world. So research in this area is extremely important. We also need to keep in mind and feel proud that only in this part of the country that this fast wireless communication was demonstrated here by Professor Jagadish Chandra Basu. Just we are bearing that legacy. that you need to keep in mind. You also need to keep in mind that the solar power engineering and solar technology in this country, this Calcutta and this West Bengal, this region, it also showed that it was the pioneer. So I hope that the conference, today's conference, that it is quite encouraging to see that although the conference is organized in a college, but a large number of participants across the country and also from this international forum, they have decided to participate here. So that tells this importance and the significant impact that this college is making in this area of this education, about this engineering and also this communication technology. So I hope that this conference will be a quite successful conference, and the outcome of this conference, I would request that this principal, Professor Shakar, to make it brief, abstract, not only that whatever the participants are there, but the deliberations, that so that it can give guidelines to these other educational institutes as well. So with these big words, I wish for the success of the conference. Thank you very much.
Thank you, sir, for sharing your knowledge and enriching us with your thoughts. It is my great honor and privilege to introduce our distinguished guest of honor, Dr. Trupti Ranjan Lenka, Associate Professor in the Department of Electronics and Communication Engineering at NIT Shilchar. Dr. Lenka is a renowned researcher in the field of microelectronics, nanoelectronics, VLSI design and energy harvesting. With over 2 decades of academic and research experience, he has made remarkable contributions through 250 plus publications, multiple patents and several sponsored research projects. He has also been associated with prestigious international institutions such as New Jersey Institute of Technology USA and the Solar Energy Research Institute of Singapore, further strengthening his global academic footprint. A recipient of numerous accolades, Dr. Lenka continues to inspire scholars through his innovative research and leadership. Please join me in warmly welcoming Dr. Trupti Ranjan Lenka for his insightful session. Please, sir.
Very good morning, one and all. Thanks for nice introduction. Honorable Padma Shri Professor Rajay Kumar Ray, former Director IST Sipur. Honorable Vice Chancellor Macaut, Professor Tapas Chakraborty. Honorable Director NIT Warangal, Professor Vidyadhar Subodhi sir. And Honorable Principal of GIS College of Engineering, Professor Partha Sarkar sir, and the organizing committee of this conference, and delegates on the dais as well as on the dais, students, volunteers, and my students, friends. I am highly privileged finding myself in this August gathering, and I am very much thankful for getting this invitation from the principal of GIS College of Engineering and the organizing committee for visiting to this great institution of GIS College of Engineering. I must appreciate the founder of this great institution who was established so that actually we have gathered over here today because of their contribution to the society and founding such a beautiful institution where the budding futures of India, of the globe, they are studying over here and create legacy in these institutions. And I must thank the organizing committee organizing such a great conference on advances in communication, biomedical, electronics, and in smart grid automation in very broad way they have figured out this conference theme, and more than 190 papers have been received, and out of them around 70 have been accepted. It is a great sign that great quality have been maintained in this conference. And this is my first visit to the institution and second time I have come to Kalyani. So I accepted this invitation whenever the organizing committee sent me. And a few days back I was thinking whether I will go or not. But now I am thinking of, I have taken a very good decision that I could able to, because the program schedule was not announced earlier. So it was a commitment earlier. So whenever the program schedule came, then I find who are the people with whom I can meet. So I am finding myself fortunate enough that I am able to meet Padma Shri Ajay Kumar Here sir, because he may not recognize me by face or by name, but whenever I told I am from NIT Silchar, sir immediately recognized. So how are you? He asked me how are you, because we are having a interaction earlier, so that he immediately recognized and asked me how are you doing now, how are you doing, how NIT Silchar is doing, because he has also great contributions in last several years. And I must also thank the director NIT Warangal, Professor Vidyadhar Subudhi sir. He has also come here, general chair of this conference, and I get the opportunity to interact because I had interacted long back, but again after a few years gap, again I am able to meet. So this is because of the principal of the JIS College of Engineering, Professor Partha Sarkar sir, and I must thank that he has invited me, and I extend my gratitude to the organizing committee. They have also invited me. And I would like to share a few things about my research journey. And I must appreciate the students, those who have contributed this conference as well as those who are attending this conference. Because every students are studying some courses. But out of that, what is the value added? This conference is the value added. If you are attending this conference, you will get some knowledge, some exposure. Next time you will try to participate. Can I present a paper in this conference? Or similar conference, can I attend in other place of JIS college or any other cities? Because conference attendance is very, very important. Whenever you are going for a conference, you are meeting people there, and that meeting people is very great. So you will create your network. You will interact with scientists, you will interact with professors, academicians, innovators. So this is great opportunities. So this conference must be organized. And for your kind information, my association with NIT Silchar since 2012, and there is a program microelectronics and VLSI design MTech. So during COVID time, everywhere was locked down in their homes. So I was also locked down, and I thought, how can I contribute so that actually outside world we can communicate. Actually, I am an active member of IEEE Electronic Devices Societies, and I started a conference that is my brainchild. I interacted with my close colleague, let us do it. Then we started doing it, and 2021 we started the journey of the conference, and I named Micro Nano Electronic Devices, Circuits and Systems. So this is just one activity I had started, and now it is a global conference in the globe. 6th edition actually we have done it. Every year we do publications and extended version also in journals. And the objective is the conference to interact outside world. You can bring people, okay, so that the students, the community, they can benefit out of the interactions. That's actually very, very important. So the students who are studying microelectronics and VLSI, for them it is a golden opportunity. They can directly interact with the people, with the academicians, with the experts. So this is because of IEEE Electronic Devices Society. We have started a branch at NIT Silchar. If you do not have, so I encourage the faculty members, they should take initiative. If it is not there, if it is there, it's fine. and I am actually active member at TDS, and I appreciate students. They should come forward and attend the conferences which are organized on electron devices societies. And in this line, JIS institution, JIS College of Engineering, I think it is doing great, because whenever I came, I saw the patents, the award grant letters, they were actually binded and portrayed in the walls. That's a great innovative idea. I appreciated, sir, that is a great idea, because JIS College has already filed patents more than 500. This is great, really great. And I see lot of projects, their award letters have been portrayed very nicely, so that visitors can see, visitors can understand what is the potential of these institutions. So the faculty members, they are actually the pillar of these institutions, they are the backbone. So faculty members, they will encourage the students. So faculty members should be focused, should be encouraged for doing research, because nowadays only teaching is not great actually. So you have to adopt research. So now research has come down to undergraduate level. Earlier only PhD students, they are doing research. Master students were just going towards research. But nowadays research has come down to undergraduate level. Undergraduate students, they are given this exposure, they have given these opportunities under the guidance of the faculty members and under the umbrella of conference, so that student will do innovations, and that innovations they will write in the form of paper, and the papers are published, and the papers are now stored in the digital library. Whenever you will write your name in Google, then your papers will come in the form of Google Scholar database. So it gives lot of happiness those who are doing research, and I encourage the students members, they should come forward and involve in research, so that you will have a great life in your career. And I must thank the organizing committee and the JIS College of Engineering for inviting me, for giving me an opportunity to visit your institution, and in the first glance, I appreciate you people are doing wonderful. Thank you all.
Thank you, sir. Your thoughts have added great value to the conference. It is my great privilege to introduce our guest of honor, Padma Shri Professor Dr. Ajay Kumar Roy, Director, JIS Institute of Advanced Studies and Research, former Director, IIEST Shibpur, former Professor, IIT Kharagpur. Professor Roy is a distinguished Indian academician, researcher, and institutional builder.
A very good morning to all of you, dear participants, distinguished academicians who are listening on the dais. Professor Partha Sarkar, principal of this college, and he is also the vice chancellor of JIS University now. Professor Chakraborty, who is the vice chancellor of Macau, not very far off from this place, a very distinguished academician. Professor Subudhi, who is the director of NIT Warangal, one of the best NITs in the country. Professor Lenka, whom I really remember a lot, because in NIT Silchar, during my interactions, I found he was one of the outstanding faculty members and researchers in that NIT. So the faculty members, probably sitting here, and all others, you are really doing great, and you have chosen a very good theme. That is 3 departments joining together: biomedical engineering, electronics, and electrical. Now this is an era of convergence. Okay, everything converges. Yes. So it's not that in the earlier days we used to say that you are in mechanical engineering, I am in electronics, he is in civil, and we did not have any communication with each one of you. Today, all the engineering and science departments, they have converged together. Professor Chakraborty just now mentioned that in healthcare, for example, in healthcare, almost 90% of the devices, the instruments, For example, the imaging systems, everything is based on fundamental science and technology. It has got electronics, it has got electrical, it has got computers, and in all that you do today, it has got, communication, because after all you have to communicate, transmit from one place to another, the signals. So it is very important that you have to understand one thing, that today all the disciplines, they are converging together. Don't think that, okay, I am in electrical engineering department, I will not be taken in computer science. Everybody has got the right to do everything else. For example, in my institute, we have got a large number of science faculty members. They are from chemistry, they are from physics, and also from engineering disciplines. So it's a convergence of the knowledge bases coming from different places. Now, my dear friends, the era that we have entered is a very difficult situation throughout the globe, and it's very exciting era when you are growing up. That is, you all know that we are now in the era of AI, and machine learning is a part of, artificial intelligence. Now the point is, how is it entering almost all the disciplines? Today, you cannot think about the next generation biomedical imaging devices, okay, or the detection systems where AI will not be incorporated. Those who are in electronics department, one of the things is on communication, telecommunication. You know about, we had 3G, 4G, 5G. Now we are entering 6G era. And it is completely, in 6G, AI is an integral part of 6G communication, even in 5G also. So you have to understand that how this artificial intelligence is slipping in everything that we do. In electrical engineering, one of your topics is on smart grids. How do you make a smart grid? So grid technology today, in fact, Professor Lenka was mentioning that, and Professor Sarkar also, that we have got, today this is an era where lots of different sources of energy, they are giving us the energy. Like say you may be getting energy from solar thermal energy. You may be getting energy from solar photovoltaics. এই ইনস্টিটিউটে আছে আমাদের সোলার ফটোভোল্টাইক্সে, আপনাদের রুফটপে আছে তো, very good. Now, for example, tomorrow you can decide that there must be some canteens. So whatever the waste things from the canteen are coming, or there may be some hostels are not there, or if there is some hostel, so from the hall of residence, lot of food stuff is coming. Now what you can do is that you can have a small biogas plant, and you can generate some small energy out of that. Tomorrow, very sensitive, wind energy systems are coming out. Earlier days we were not getting much of wind energy. I think Professor Sarkar can think about installing one wind energy, small. I am not saying that it will be big, but even if you can generate, 2, 3, 4 kilowatt of energy from wind, that will be good. Now comes so many different sources of energy. One is coming from solar photovoltaic, from your solar panels. One is coming from your wind. One is coming from your biogas plant. Now, these 3 or 4 things will have to be connected with the grid. So, electrical grid from where we are getting all this supply. So, everything, if you want to connect it properly, then you need a smart grid which will be based on AI. So it is very important and very interesting that we have entered an era where artificial intelligence and machine learning, it is entering almost all the disciplines that we can think about in area of even business, in the area of healthcare, transportation, energy, water, everywhere. Water problem is a perennial problem in many Indian cities. And you can think about that how AI can be involved. Now AI has become a buzzword today. Everybody says, I'm working on AI. At times, I think that in any university, if you throw a stone, then the probability that the stone will fall on the head of a person and that person is working on AI, that probability is very high. It will surely fall on somebody's head who is working on AI, if he is from final year or pre-final year student. So everybody is working on AI, but my dear students and also the faculty members, we have to really learn it and learn it properly. So generative AI and how the AI is influencing our life today and all the different applications in different areas. Communication is a very important area, healthcare, biomedical systems, devices, disease detection, everything, if we can combine together, then tomorrow's education will be an integrated education, a convergence education, and the education where the basic principles of basic science are very important. Remember, my friends, mathematics is very important, physics, chemistry, everything is very important. So I have decided to, give you, keep a few books on mathematical puzzles, which you can, Professor Thakkar can keep it in the library. Every night you must solve 2 to 3 mathematical puzzles. Keep your brain moving, please. And that's the way, because tomorrow it's not going to be very easy. I can tell you, things are not going to be that easy for engineers tomorrow. So all that you need to know is what is coming next and what we need to learn. Whatever you are learning today, it will become obsolete after 7 years, 5 years, 8 years. So you have to have an analytical mind so that you can accept the newer things. How to develop that brain, analytical brain? For that, you need to have a very good sharp mind, and that sharpness can be enhanced by, I still try to use, nowadays I have become too old, but then solving a few problems at night before going to bed, that is a very important hobby. Think about, try to get the problem next day morning. Remember that whatever you are learning from your other subjects, this very simple thing, absolute with concentration, trying to solve a new problem. Maybe that one day I can come and we can give some interesting and make it, very interesting. We can have some session with the students, and then I can tell you lots of interesting problems. Finally, you will find that those problems are connected with your own disciplines of engineering science, that is communication, biomedical, or electrical engineering, etc. All the best, and thank you very, very much for organizing this conference, and all the best to all of you.
Thank you, sir. We are grateful for your inspiring address. It is a matter of great honor and privilege to introduce our esteemed Conference General Chair and Chief Guest, Professor Dr. Vidyadhar Subudhi, Director of NIT Warangal. We are fortunate to have you here in JIS College of Engineering, sir. Professor Subudhi is a distinguished academician and an eminent expert in control systems and electrical engineering. With an illustrious career spanning decades, he has contributed extensively through high-impact research publications, guided numerous doctoral scholars, and led several prestigious research projects. His vision for fostering innovation, interdisciplinary research, and industry collaboration continues to strengthen the academic ecosystem. May I now request Professor Dr. Vidyanesh Subudi to kindly address the gathering. Please, sir.
A very good afternoon to all. I'm really privileged to be here amongst you. And it is a distinct pleasure to greet some of the finest academicians, Professor Ajay Roy and Professor Tapas Chakraborty, Professor Bas Sarkar, Professor Lenka, and the entire professors of this wonderful institute, JIS College of Engineering. So first of all, I must thank this institute to conceive this wonderful idea to have a convergence of three areas of immense importance today. One is the communication, medical electronics, and smart grid. So all of them are very important to us in several sense. Because if you look at a conference, I believe I compare it as a marriage ceremony, any marriage ceremony you took. So that is many stakeholders have many takeaways. They have many takes from a marriage ceremony. Like the parents always want that the ceremony should be blessed with their children, and the guest always expect a good kind of dinner or something. And the youngster always find a couple of girlfriends or boyfriends there. And that way always the marriage ceremony is very, very interesting. I believe these conferences are similar to academic marriage ceremonies, where the lot of expectations are there from different stakeholders, the participants or the delegates. Like the academician or the researchers, they congregate to exchange their views on the upcoming research and the problem they are encountering and the way forward. And the institute is benefiting in terms of making it a visible progress in the state-of-the-art technologies. And also good food, good culture, good tourism, everything, so all inbuilt in a conference. I could see that Calcutta is one of the best places where these conferences rightly organized. But I would have been more glad if I could see more foreign participants. But what Professor Partha Sarkar said, because of the this war, I think that has hindered in attracting the foreign delegates to here. Nevertheless, I believe that some of them will be in online as well. So truly it is very, very inspiring, very, very acknowledging that in the current era, this kind of conference, and I also learned in the second in the series is being organized. Because normally what happens, many institutes they organize a conference and they forget it. So, but I realize that the way the JIS is doing, it is good, the culture is good, because the second edition, third edition, and so it should continue in the focused direction. Now, if you talk about the theme of this conference, there is a convergence among these three. Like the communication, when you talk about, it is no more connecting the world. It has made us so kind of convenient to reach out to many things. Like you heard, like the remote surgery. You see the best brains of the surgical doctors, they are stationed somewhere and they could operate a patient. It is done through robotic surgery. So that is possible, and the healthcare is truly influenced or impacted by the progress in AI. Like instead of a generalized kind of treatment. Now it is possible to have a personalized treatment. And also you see the progress in the medical service, medical healthcare. So where a lot of AI and this communication and they are really wonderful. Recently I had been to one of the hospitals in Hyderabad, care hospital, and I took some of my relatives there and I was discussing the doctor, and the doctor asked all the reports and then he told something. I was about to respond him and he was not responding to me. I was astonished why he was not responding to me. After his conversation was over, he was telling me, no, I am not asking you anything, I am asking my computer. I gave the diagnosis report to the computer. I am asking the computer to generate a prescription for me. Hyderabad, care hospital, it is progressing like that. So the technology has made our life very simple, and so this is not only this communication is this 5G or 6G. This communication is very important in the health sector as well, because the patient monitoring and the AI drones communications, and I was told that the drone market, AI and drone market, has an enormous potential in both business and the research and the employment. So therefore I will urge that JIS could think to open up a course in our program in AI and drones. Possibly we have a large potential there. And then we have this smart grid automation. So you please understand. So the blackouts, not only in US, not only in India, when there is a power failure, to get the fault diagnosed, it takes a lot of time. When a tree branch is falling somewhere, to know that where the fault has occurred or something like that. So now you could see that the smart grid technology, it has made the diagnosis so fast using the phasor measurement unit, using the concept of synchrophasor. So the diagnosis become very fast, and also integrating several sources of energy, not only the photovoltaic but also to like the wind or maybe the whatever renewable energy sources like fuel cells or biogas or tidal wave, whatever we talk about. So the best advantage that we are witnessing today, the grids are no more dull, they are becoming smart. What we call as the smart, they are integrated with the advanced communication technology, computing, and also the kind of the advanced control techniques. So therefore, the grid is now very resilient, and the fault etc. can be easily tracked, and we get a very, very consistent and power quality from the grids. And the most important thing is the dispersed power generation. That means instead of investing a huge amount of money for a centralized power location like a thermal or hydel, we can think of the distributed power generation. We can localize a particular area where you can have your own generation. And now the added advantage is that because of the smart grid that facilitates the integration of so many renewables, it is also possible to integrate the electric vehicles and the bidirectional charging of the electric vehicle in the smart grids, where we can get the carbon footprint decreased because of the renewables in the place. And on the other hand, when there is a blackout of the power generation, you can get back the power through integration of the idle EV, which from the vehicle to the grid as well. So a lot of advancement has happened in these three directions in the recent years, and I believe this kind of conferences will stimulate the brains, the young brains, like who are today undergraduate students. They are also more, kind of sensitized, because those days are gone, because the research is not limited to the PhD students. Now in NIT Warangal, we started research as a credit course in the first year BTech itself, because I believe that the student must be sensitized for research from the first semester. They will contact some of their professors of interest and discuss with a very, very state-of-the-art problem and have some literature. They will do some fine programming or hardware, and eventually they can take a career in the research. So therefore, seeing a lot of BTech students here, I am quite impressed that really the research has gone to that level. And I believe that this kind of activity in the JIS will definitely enhance the research outcome in the future. Because today when you talk about a research outcome, maybe a research project, maybe a patent, maybe a transfer of technology or a translational research, that all happens by the knowledge dissemination. And therefore I believe that this conference, where a lot of the young brains and the delegates are here to discuss and to think that what way the research can be taken at the next level. For example, JIS may not be so big research we expect. What is tangible? So let us think about it. I am not unsure, I am not surprised. Why not some patents on the simple ideas of the young BTech students can be filed as patents? And thereafter those patents can be translated to some kind of useful product for the industries. And now the key to the research outcome is no more only the research publication or the patents. It is basically a small tiny kind of product development or ideas or innovation that will reach out to some of the industries in some form. So let us, because you might have read the newspaper recently, China has now translated the PhD thesis, instead of the thesis, the product-based PhD kind of guidance. So let us think of these kind of ideas and come up with some of the best ideas and some of the takeaways you should promise what you should achieve. Because conferences, as I mentioned in my first introduction speech, that it's not only the enjoyment, it's basically we should expect after the end of the conference, what are our takeaways? So we should plan it every time you conduct a conference, you should list that what are the benefits I got from the conference. Like I would expect, I will put 1 to 10 takeaways from this conference. One could be the how many good publication presented here, papers presented here could be extended to publish in the best journal. How many ideas from the BTech student come out to as patents? How many of them are translated to some products? How many collaboration you can have some of the foreign universities or the universities within the state, within the country? That is another takeaway. How many students will take a career not as a job seeker or as a job provider by having their own startups? So let us have our mind, utilize our mind in searching for the best benefit out of this conference that we are organizing. So I am very glad to be here to see that it is wonderfully organized. I congratulate the entire team of JIS and all the delegates here to making it happen so nicely. And I wish this conference a grand success, not as a conventional conference, but a conference that will bring a lot of success in terms of transfer of technology, in terms of a Section 8 company that JIS could think of, and connecting industry and finding out their problem to take it up here. And you can connect with some of the ministries, like the Ministry of Electronics and Information Technology, which is tremendously supporting now the institutes to take up the projects forward. And there are particular grants for AICT now for transfer of technology. Like if your academic research is at the level of, let us say, TRL 2, 3, 4, you can make it TRL 7 or 8 for the benefit of the industry. There are special grants that are available. Let us take this, that is called AICT RPS program. And also there are a lot of incubation advertisements are coming up, call for proposals are coming up. I believe that let us leverage all of them and best benefit, and ultimately when any institute, any conference think of that kind of research prosperity, the country will grow in the forward direction. Because today if all of you look a simple comparison, some 30 years ago, 20 years ago, when a mobile phone was not possible to anyone, even very handful of people are using. Now you see any common man is using a mobile phone. It is because possible. It is possible because of the research basically. So let us believe that this conference will throw some light in this direction, how to produce some products which will be inexpensive, which will be very, very efficient, and our only classroom teaching should be not limited for some kind of academic learning. The academic learning should be leveraged for the best benefit of the mankind, for the best benefit of the industry, and I believe this conference is a way forward in that direction. And I once again thank for the entire organizing committee, including the principal, Professor Partha Sarkar, for inviting me. I wish this conference a grand success. Thank you very much.
Thank you, sir. It was indeed a privilege to listen to you, sir. May I now request Dean Academics, Dr. Shomabrata Saha, to say few words.
Very good morning, respected Honorable General Chair, Professor Vidyadhar Subudhi Sir, Director, NIT Warangal, respected Honorable Vice Chancellor, Maulana Abul Kalam Azad, Professor Technology, Professor Tapas Chakraborty Sir, respected Padma Shri Professor Ajay Kumar Sir, respected faculty members, respected Trupti Lancashire, all the conveners of the International Conference on Advances in Communication, Medical Electronics and Smart Grid System Automation, the HODs of the Department of Electronics and Communication Engineering, HOD Biomedical Engineering and HOD Electrical Engineering. I welcome all the participants in this conference. With the special note, I want to mention for a few on behalf of the GIS College of Engineering. Those are the young researchers, the students, those are publishing the paper over here. There is a small request to all of them. Whenever you are presenting your paper, you kindly carry forward the suggestion of the session chairs. Whenever you are presenting your paper, whatever the suggestion session chairs are mentioning their advice, you kindly note it down and carry forward that particular for your further research. On behalf of GIS College of Engineering, I want to inform all the dignitaries that our college has been organized 3 international conferences in a calendar year. We are starting this initiative under the guidance and directive of our Honorable Principal Sir from 2024-25 academic years onwards. That this year we are all starting with this particular first conference in this time in the month of March, April. Next we are having 2 other conferences in this calendar year, and everywhere our students are participated. Not only our students, the students from the outside of the state and the participants from the outside of the country also. That it is a great success of our institutions, that the one institutions are organizing 3 international conferences in a calendar year. That is a remarkable success of our institutions. And one thing I want to mention on behalf of our GIS College of Engineering, that all the conferences, those are we have already hosted, we have already organized, including this conference, all the publications are the English publications, where our students are publishing, the young researchers are publishing, outside of the institution, the students are publishing. All the publishing paper are in the index, are available in the Scopus author profile and Web of Science author profile. Without the further delay, I conclude my speech over here because there is a program there. Thank you all the best.
Thank you, sir. Now it's time of opening of book of abstract of this conference, Acmesga 2K26. All dignitaries present on the dais are requested to do the honor, sir and ma'am. Thank you. May I now request Dr. Korobi Ganguly, Head of the Department Biomedical Engineering Department, to kindly deliver the vote of thanks. Good afternoon, distinguished dignitaries, honorable guests, esteemed faculty members, researchers, participants, and dear students. As we conclude today's inaugural session of Second International Conference on Advances in Communication, Medical Electronics, and Smart Grid Automation, that is Acmesga 2K26, I stand here with a deep sense of gratitude to acknowledge those who made this vision a reality. We begin by bowing our heads in profound respect and remembrance of our late founder. We express our eternal gratitude to late Sardar Jodh Singh Ji, the visionary founder of JIS College of Engineering, and our beloved Babuji, and late Satnam Kaur, our beloved Mataji. Their legacy of educational excellence continues to guide every step we take. Our heartfelt thanks go to the leadership of this JIS group for their unwavering support. Sardar Taranjit Singh Sir, Honorable Managing Director, JIS Group, for his inspiring leadership and guidance. Mr. Simarpreet Singh, Honorable Director, JIS Group, for his encouragement continuously. Professor Dr. Parthu Sarkar, Principal of JIS College of Engineering and Conference Program Chair, for his constant guidance, motivation, and advice. We are deeply indebted to our chief guest and guests of honor for sharing their invaluable time and insights. Respected Professor Dr. Vidyadhar Subudhi Sir, Conference General Chair, our Honorable Chief Guest and Director, NIT Warangal. We express our sincere gratitude, sir. We express our heartfelt regards to all guests of honor. Professor Dr. Tapush Chakraborty, sir, Honorable Vice Chancellor, Maulana Abul Kalam Azad University of Technology. Padma Shri, Professor Dr. Ajoy Ray, sir, Director, JIS Institute of Advanced Studies and Research, former Director, IIEST Shibpur, from Professor IIT Kharagpur. Dr. Trupti Ranjan Lenka sir, Associate Professor, NIT Silchar, and keynote speaker. Professor Dr. Anshuman Sarkar, Kolani Government Engineering College. Our technical horizons as expanded by our all other honorable keynote speakers, technical experts across globe, international and national advisory board members of Acmesga 2K26. Dr. Basuki Rajmatul Alam from Indonesia, Professor Dr. Charles Zhang from China, and Dr. Marta Zurek from Poland. Our sincere regards and thanks to all of them. We thank the academic leadership who streamlined this endeavor. Dr. Shomabrata Saha, Dean Academics, JISE, Professor Dr. Shandip Ghosh, IQSC Director, JISE, Dr. Devashish Shanki, Register, JISC. We also extend our thanks to our respected session chairs who meticulously moderated the technical tracks and will provide constant resourceful guidance to the researchers. Dr. Shandip Nandi, Dr. Shiv Shankar Saha, Dr. Pranay Sharma, Dr. Raj Rajeshwari, Dr. Mohan Kumar, Dr. Chittaranjan Nayak and Dr. Deepak Kumar Das. Prior to thanking the organizing committee, I should mention the Sanskrit sloka, Vidyattancha Nipattancha Naivatilyam Kadachana Swadeshi Pujyate Raja Vidyan Sarvatra Pujyate. The platform of this international conference is the proof of that visionary and academician, educationists, researchers, who never be compared with the king, because king is worshipped in his kingdom, but the academicians, the visionary, are worshipped every corner of the globe. The organizing committee, a special mention to the conveners who are the driving force of this conference, Dr. Alok Kumar Srivastava, Dr. Momita Pal, sorry, I am mentioning also my name, Dr. Korvik Ganguly, Professor Dr. Indranath Sharkar, General Secretary of Acmesga 2K26, our dedicated session coordinators, Dr. Anirban Patro, Mr. Vishwamoy Paul, Dr. Dibyendu Mondal, Dr. Madhura Chakraborty, Dr. Ovijit Paul, and Dr. Arnab Shore. Our acknowledgements to the wider team. Finally, we extend our gratitude to the reviewers for ensuring the highest technical standards for the accepted papers, all deans, HODs, faculty members, staff members of JIS College of Engineering for their behind the screen, behind the scene coordination, selfless, tireless supports, especially 3 organizing departments, Electronics and Communication Engineering, Biomedical Engineering, and Electrical Engineering. All the researchers and authors who has contributed their valuable research work and will present their work across the various technical tracks. Our press and media partners for providing the conference with the coverage it deserves. Our energetic student volunteers who are managing the logistics with a smile, and the student attendees for their enthusiastic participation. Thank you all for being a part of Second International Conference on Advances in Communication, Medical Electronics, and Smart Grid Automation. Acmesga 2K26. We sincerely hope that all the sessions which are a part of this conference over the next 2 days prove to be resourceful and, most importantly, a worthwhile experience for all of you. Wishing you all the very best of time and health for the days ahead. Thank you very much. Thank you, ma'am, for your heartfelt vote of thanks. We now move on to the next session of our program, that is keynote session. It gives me great pleasure to welcome our esteemed keynote speaker, Dr. Trupti Ranjan Lenka, who will be delivering the keynote address today. Please, sir. All of the dignitaries on the dais are requested to have a seat. of you have your seat. It will be a valuable session. You will gain something from that. So please listen carefully.
Good afternoon, one and all. Myself, T.R. Lekka from NIT Silchar, and I will be happy to present a work on resilience of Algan hand sensors for biomedical applications. So this is NIT Silchar. Actually, those who are not knowing where NIT Silchar. Okay, so this is very near to Bangladesh. Okay, very well connected. There is a train communication from Kolkata to Silchar, then Agartala. Nowadays, train communication is good, and flight communication is also there from Kolkata to Silchar, 1 hour flight. And this is my research collaborations. I have worked on third nitride high electron mobility transistors modeling, and so far 6 PhD students they have been awarded under my guidance, and MEMS for energy harvesting. 2 PhD they have worked with me, solar photovoltaics 4 PhD, and opto nanoelectronics, and this experimental research growth of TiO2 nanowires for photodetectors. And currently I am guiding 3 students on power electronics and sensor and solar photovoltaics. And I am associated with some few of the institutions worldwide, and actively some publications, collaboration projects also there. So very recently I had visited, this is Texas Tech, United States, and I have a Bachelor project with one of the professors there. The professor had come to NIT Silchar, stayed 1 month, and I had been there to Texas Tech also. I have stayed there more than 6 months, and some other institutions I am associated. And these are my PhD students. They have worked on LEDs, very recent student. So their number is 1, and who has passed out in 2016, that is number 15. So mostly I have worked on high electron mobility transistor because this is my strong area of research, that modeling and simulations and experimental also, but experimental is actually done in Texas. So today's talk will be of around 25 to 30 minutes, and the talk is an introduction about the semiconductor on power electronics and some evolutions and the device, how it is resilient for sensor applications. So this is the flow of my talk, and so far we are dealing with silicon based devices, as you know. Okay, all gadgets you are using, okay, for taking pictures, mobile phones, all are silicon based, but it has certain limitations. Silicon devices almost have reached its limit. It has already explored a lot, and scientists, researchers, they are exploring more and more on advancement of the devices. So nowadays the materials actually on research, gallium nitride. So germanium and silicon, as you know, these are elemental semiconductors and very well matured and commercialized. But nowadays gallium nitride is now focused. All over the globe, the researchers, they are focusing on gallium nitride. Whenever I did my research on gallium nitride in the year 2012, that time it was not matured actually. That time people were very less working, but nowadays a lot of people are working and a lot of experimental research, but in our country still it is not mature. Still we are struggling because we do not have enough infrastructure for making the growth in making the devices. IIC Bangalore, they have started doing because the West Fabrication Institution in IIC Bangalore. So these are the two systems I have shown in the diagram. One is very rough surface, one is very smooth surface. So the purpose of showing this figure, that we are having MOSFET, and our BTech students, they are studying this MOSFET in their curriculum, electronic students. Okay, so in MOSFET, whenever the surface is smooth, then more electrons, very easily electrons will flow. And when electrons will flow, then we will get current. And whenever we are doing any semiconductor device, our objective is how much current flows. If current is not flowing, then there is no point of making a device. And you are able to stop that current. So you are making the current flow and you are stopping the current. Then you make it as a switch. So that is actually the objective of the device. Whatever device you take, whether it is a diode, PN junction diode, whether it is a BJT, bipolar junction transistor, or a MOSFET. So the purpose is how much current is flowing, whether the device is on or off, and after current flow, whether I can make the device off or not. Because you are making on and off. That's the objective of making a semiconductor device, which is used as a switch. So whenever we are having a good surface, very easily electrons can flow. And how can we make the surface smooth? So we have to do some material science. So these are materials, electronic materials. So we have to play around with this material science, and we will make the surface very smooth, so that the device will give a better current, more electrons flow, and will get lot of current. So the gallium nitride technology actually started. Why it is called technology? Because this is new material. Okay, and the scientists worldwide, they are focusing on this material, exploring, making new devices. Okay, and this gallium nitride material is very emerging actually, and it is actually nitride. Okay, and wide bandgap semiconductor, bandgap you see 3.4 electron volt. Okay, and more than silicon or germanium. Silicon is very abundant in nature, so that our silicon chips, they are actually available. Whatever gadgets, laptop, mobile phone, whatever you take, the silicon you will get. But gallium nitride is sophisticated for certain applications, optoelectronic applications, power electronic applications, and automobiles. So I will show you a lot of applications actually. where gallium nitride is not there, you see. Nowadays, various colored LEDs are available. LEDs are used in traffic lights, okay, yellow, green, red. Nowadays, LED tube lights everywhere. The fluorescent color tube lights are replaced with LEDs. So LED gallium nitride is suitable for giving LEDs and different colored. Okay, and in LEDs, light emitting diode, my research collaborator is pioneering LEDs. Okay, he is working on gallium nitride LEDs. So wherever we started collaborating, he came to know that I have expertise in gallium nitride power devices, and he has expertise in LEDs. So he invited me that you come, our research areas are matching, and we can do something good. So that I started visiting in 2019 for few months there. Okay, and we started collaboration. And started collaboration in 2019 on LEDs. I learned LED from him, and he learned hemp from me. Now he is, you can say, hemp expert because he has MB, molecular beam lithographies. He has big infrastructure. So now he is learning hemp, high electromobility transistor, and he has started working on power electronic devices. He again invited me that you come and do your research here. So these are actually the opportunities in third nitride semiconductors. Nowadays the automobile sector in cars, whenever we start the engine, huge power actually they are actually generated, and our motherboard should sustain, our device should sustain a temperature of 600, 400. Gallium nitride devices, it can sustain temperature of 1000 degrees, where silicon devices cannot. So therefore gallium nitride high electron mobility transistor, this is nothing but a MOSFET. Okay, so they are in power electronics, in automobiles, okay, in space, okay, many SMPS in computers, our desktop SMPS is there. Everywhere this semiconductor device used as a power device, and we can see starting from our laptops, okay, and photovoltaics, wind energies, this is the hybrid electric vehicles, okay, rail traction, everywhere in power electronic applications, device is useful in the motherboard for controlling the electronics. So there actually this gallium nitride high electron mobility transistor is used. Stop this.
Close করে দাও, close করে দাও, close করে দাও।
This is one of the best example I would like to give. Okay, I have taken it from Gallium Nitride Power International. Okay, this is one of the industries. Whenever I was in United States, I was doing some experiment. So we had bought some ICs from this company. It's a Canada-based company. We had bought some ICs and I characterized with the characterizing equipment. So nowadays we see our laptops. It has adapter, big adapter. Okay, very heavy to carry. And that adapter is going to be a small adapter, just like a capacitor, earlier age capacitor. So it is going to happen. Okay, this is because of this device, gallium nitride device. And in our solar panels, so there is an inverter inside the motherboard. There is circuit is there. So this gallium nitride head is there. And this is actually upcoming. Still in many cities it is available. Okay, so this is called EV charging stations. Nowadays EV scooters have come. So there is a EV charging station is there. Inside the EV charging station, this device is there. You will not get silicon type MOSFET. You will not get. This device you will get. Okay, because this device will sustain for huge temperature as well as handle large voltage. And data centers are there nowadays. Okay, I had established a data center in 2014 at NIT Silchar. First data center in Northeast under the help of CDAC. Okay, that data center. I also learned what is a data center. I went to CDAC and I came to know what is data center, and we established, okay, by spending a lot of money. Okay, and in the data center actually huge power actually used in the data centers. And whenever you are using MOSFET based integrated circuit in the motherboard, in the cluster inside the data center, so huge power actually used. So if you are replacing the MOSFET with gallium nitride, this transistor, then actually you are going to save a lot of power, because it is it has a lot of efficiencies. Power loss is actually less in the form of heat. So you are going to use less energy. So less electricity bill you are going to get. And this is the EV charging station where your recent electric vehicles, okay, they are getting charged. So inside this module, so this device is there. So now in our day-to-day life, we are dealing with these examples. So these are the evolution of MEMS in power electronics. Started 1975 and now 2026 we have reached. These are the industries. Okay, they are pioneer, okay, in establishing the devices. So the electronics engineers, those who keep interest in semiconductor, they should focus this company. Can I get internship in this company? Can I get a job? Can I have a great career in these companies? Because they should focus. These companies are semiconductor companies. Okay, so Fujitsu you know, Toshiba you know, and lot of companies you know. Infineon is based in Bangalore. It is one of the companies. Students are getting opportunities to do internship. You can also get that. Okay, so therefore I have shown you this diagram. And this high electron mobility transistor market nowadays is very booming. And you see, up to 2033, $800 million is actually it's the target, because every companies they are targeting on gallium nitride. In 2024, I had a short visit to United States, and there was a company, okay, and the company founder is in Indian-based company. So some channel they could know about me that I work on gallium nitride. So they had also invited me to their company and had a discussion, because they are getting a lot of projects from United States government and they are going to focus gallium nitride chips. Okay, so people are thinking how to make gallium nitride chips. So gallium nitride material is now enormous potential. Okay, and in India we are focusing on only modeling and simulations because of our lack of research opportunities. So what is that device? This device is nothing but, I said, it is a MOSFET. Okay, MOSFET metal oxide semiconductor field effect transistor. So you remove oxide. Okay, you directly contact your metal with the semiconductor. So now it is called MESFET, metal semiconductor field effect transistor. So MESFET is taught in the courses, in electronic device courses. So this is nothing but a MESFET, but this is not made of silicon. This is made of gallium nitride. So therefore it is not called MESFET, because the materials making the device as heterojunction, heterogeneous, okay, heterojunctions are created. So this is the heterojunction. So therefore this is not MESFET, this is high electron mobility transistors. Electron mobility is very huge. I said that whenever electrons flow, you are having current. Electrons not flowing, no current. So mobility of electrons matters. And how you will get the mobility more? So you are doing engineering, band engineering. So using band engineering, actually you are giving less voltage, maybe 1.5 volt, but you are getting lot of current in milliampere. So nowadays electronics, it has come down to 1.5 volt. It is nothing but your electronic devices, okay, now operating 1.5 volt and giving lot of currents, okay, and that is a device, high electron mobility transistor. So gallium nitride, its characteristics, wide band gap, because band gap is more, and we are exploiting band engineering and high saturation voltage, high mobilities. So these are the good features. These are actually considered, so that it gives us high breakdown voltage. The device is not breaking down in kilovolts. The device is not breaking down in kilovolts. So it is good. It is sustaining lot of voltage, lot of power. Okay, and high current we are getting. And this device, whenever we are using in transistor, then we are getting high seed charge density. That is actually the main important thing about this sensor. So nowadays people are working this device as well as power electronic, but sensor is now focused. Lot of research papers are now coming up in sensors. Okay. So because it gives us high frequency operation, high output power, high speed, and high temperature operation. High speed, so therefore we are telling the performance of the device is more. And how we will measure the speed? You are putting the computer and waiting for few minutes. Your front machine is not ready to work, so you will getting bored. So many meetings, the machine is slow, and I am waiting for long time. So you will feel the machine is slow. Whenever you will go back and use older machine, and nowadays you are using i7, you will feel the difference that machine is slow and machine is now faster. So that's doing your high speed. Your transistors are not of high speed, then you will not get speed in your computer because it is doing computations. And these are the advantages we discussed: wide band gap, piezo polarizations. So this is very important thing which is not with silicon. So therefore silicon is not overtaking this gallium nitride. Gallium nitride has overtaken silicon because it is piezoelectric. Okay, and you see this is the material, and here actually electrons form. Electrons form automatically. Why? Because its band gap is more, its band gap is less. Sorry, this band gap is more, its band gap is less. So whenever growth is done, so here there is a thin sheet of electrons. Electrons form there, and that electrons forming is itself creation of the channel, which we do in MOSFET by giving potential. In MOSFET we apply potential and we create the channel, and here we don't apply potential but channel is ready, and that is good. So therefore our threshold voltage is negative. Already channel is there, they are ready to flow, but we have to give a bias. We have to give a potential difference. VDD we apply. The electronics people, they can better understand what is VDD and what is ground. So whenever you make a potential difference, then current will flow, electrons will start flowing. So the important thing is how electrons is automatically formed, and next you are making the electrons to flow. That is the objective of the device, and that is the main thing behind the device. The device engineers, they make the device. And this is actually the structure. Okay, this is the structures people do in laboratories, and you can see this is a planar device. So this is the substrate, and slowly they make the different materials. So therefore the device is called a heterojunction device, because heterostructure is created, and that heterostructure making a channel formation. So structure of gallium arsenide based head. When I started doing PhD, that time gallium arsenide was still there, but nowadays people stopped working gallium arsenide. People are now focusing on gallium nitride. Structure of gallium nitride based hand, and this is your indium phosphide based. Indium phosphide, few group of people, they are also working on indium phosphide. And this is the band engineering. This is the conduction energy band, this is valence energy band. So this is a two-dimensional electron gas is formed, where actually the channel is formed. This is called as quantum well. And the quantum well is actually the main heart of this device. The quantum well is formed because wide bandgap material grown over gallium nitride, grown over the narrow bandgap material. Means 4.16 electron volt grown over 3.4 electron volt. So because of that, this well is formed. Because of that, this well is formed. And inside the well, the electrons fall into the well and they are not able to come out. And that well is created in this device. And once the well is formed and electrons are trapped in the well, then you make the potential difference, and the electrons, they will flow, okay, and opposite to the direction of the electric field, and you will get the current. So this is the IV characteristics you have studied. The students, they have studied this IV characteristic. You have written in exams also. The standard IV characteristics as like MOSFET. Okay. So this is also the charge density. I said the charge densities are important. And in sensor, we are working on these charge densities, whether charges are being changed or not by applying voltage. So that is the sensor, we are sensing it with the help of transducer. And these are transconductance, you know, and this is your temperature, and this is the power, okay, and this is the efficiency. Efficiency of this device is more. And now we are using this concept of high electron mobility transistor, okay, into sensor. So biosensor. Okay, so why? Because it is used in sensing applications. Nowadays sensor everywhere. Nowadays we are taking photographs in mobile phone. Okay, you are sensing. Okay, optical sensors are there. So that sensor is actually you can make using this device. So there is a transducer. The device is used here as a transducer, okay, and the transducer gives us the signal, okay, and we are amplifying, and we are now monitoring in the computer, and that is done using signal processing. So here these are the analytes, okay, and various biomolecules are there, and that biomolecules are actually given inside this device, and the device actually sensing it. So this is the principle of a sensor. You can see it has two components. One is biological component because biological molecules you have to introduce. Okay, these are nothing but some proteins, enzymes, okay, hormone, antibodies. And the physical component, our device, that is your transducer, it is acting as transducer. And this device is also used as an amplifier. And the biological component recognizes and interacts with the analyte to produce a physical change. That physical change we introduce in the form of signal that can be detected by the transducer, and the transducer gives the signal and amplifying, okay, and going to the processor, and in the processor we are going to see the device, see the changes. So this is actually the transducer, okay, high electron mobility is used here actually, and these are the biological components. They are invited, okay, and they interact, the transducer showing the physical change, that physical change in the form of current, and the signal is amplified, processed, and we analyze the signal. So these are the bioreceptors, okay, enzymes, DNA, antibodies. So we use them, but in modeling and simulation, how we use them? We use the dielectric. We change the different type of dielectrics, and those who are having facilities, they can do it in laboratories with different chemicals. And the biosensors have been classified with amperometric biosensor, potentiometric biosensor, thermometric biosensor, optical biosensor. Different type of biosensors are there, and this is your analyte, okay, and this is the transducer. This device is used as a transducer, and the display, the signal change. This is the signal is shown here. And the sensors are used everywhere. Okay. Nowadays the sensors are very important in our biomedical applications. Without sensor, the doctor cannot diagnose properly. So the doctors nowadays facilitating, they are getting facilitated using the sensor-based medical equipment. So the advancement of future prospects of wearable sensing technologies. So people can wear these sensing devices in their bodies, and their body parameters are transformed, okay, using communication systems, using antennas, and the signals they are actually measured by the operator, okay, and doctor finally diagnose what is the condition of the patient. So here actually you see the communication nowadays 5G, 6G communications are used. So 5G, 6G, they can use these gallium nitride technologies. Okay, and I came to know that the BBDN technologies, okay, this is indigenous company by India. They are using this gallium nitride for making 6th generation WiMAX, okay, the Wi-Fi boxes. Inside the Wi-Fi boxes, the antenna is there, and some other electronic components are there. Gallium nitride is actually used. So your communication part is covered, 5G, 6G. They cannot do 5G, 6G without gallium nitride technology. So gallium nitride technology making the device very lightweight, very compact. So 5G, 6G depend on gallium nitride technologies. And these are the sensors. Okay, we are wearing everywhere in watches, Apple watches. Okay, and many sort of wearables nowadays we are using. Okay, everywhere this gallium nitride technology is used. And the amperometric biosensors. Okay, so they are the glucometer, which are physical structure of glucose test strips used, and this is the iron sensitive field effect transistor based pH meter. So this is simple physical structure of endochrometric biosensors. So in different technologies there. So these are nowadays present, but nowadays we are replacing them with the gallium nitride technologies. So what are the properties of biosensors? Sensitivity, because that is one of the important figure of merit. Sensitivity should be more, high selectivities, okay, multiplexing, and easy to use, long life, because the device whatever you are using is should long lasting. Okay, so that is also one of the important thing. So biosensors, first generation long back, second generation, third generation, fifth generation. Now we are in 2026, so we are gone beyond fifth generation actually. We have a lot of developments. Nowadays we are not doing silicon based, we are doing gallium nitride technology based sensors. And where applicable, these are drug discovery, disease detection, environmental monitoring, soil quality monitoring, and food quality monitoring, toxins of defense interest, water quality management, prosthetic devices. So everywhere the biosensors are used, and biosensors are, we are using gallium nitride based biosensors. So why high electron mobility transistor? And why it is not FET, why it is high electron mobility transistor? So FET, it is easily damaged, easily attacked and destroyed, okay, and poor ruggedness because it is not robust, and low thermal and chemical stabilities, non-reusable, low sensitivities. So this FET means silicon based FET. So silicon is not used by the scientist, researcher. So nowadays high electron mobility is focused. I discussed a lot of its benefits, a lot of characteristics. Wideband materials attract sensing platforms in environmental monitoring and medical diagnosis. Superior characteristics like high thermal and chemical stability, piezoelectric nature, non-toxicity to living cells, and very robust. These are lot of positive characteristics of high electron mobility transistor. So therefore they are used as sensor. One of the excellent characteristics of the heterostructure is the presence of two-dimensional electron gas. The two-dimensional electron gas is not in silicon devices, because in silicon devices this is not heterojunction, it is homojunction, only silicon is used. So therefore this is one of the interesting characteristics of this device. And mobility is enhanced using only the band engineering, the mobility is enhanced. So these are the materials. In the periodic table, everybody has studied from 10th onwards. The same periodic table, the material scientists they are using. The focused materials are hard nitrides, and here nitride, aluminum, so aluminum nitride, indium nitride, and gallium nitride. These three materials nowadays dominating optoelectronics, power electronics, and photonics, you can say. So all applications, these three materials, they are focusing, aluminum nitride, gallium nitride. Recently people have now gone into sensor. So now few years back there was no sensor research paper available on gallium nitride technologies. So nowadays researchers they have also doing lot of work on sensor, gallium nitride sensor. So the materials used, these are the materials actually. So we have focused on gallium nitride. Other materials they have also long back people have used. This is actually the device. Okay. So here actually the one pocket will be there. Inside the pocket you have to put allow the biomolecules to come and interact, so the dielectric will change. And whenever the dielectric will change, actually here there will be change in the current. Okay, so the change in current actually tells us there is a sensing mechanism. Some sensing is going on. So the change of current, that change of current because of some biomolecules. So that is actually the physics behind the biosensor. So this is some of the publication done by some researchers. This is actually the biomolecules. They are come and made the interaction with the aluminum gallium nitride is a pocket. They are introduced and the sensitivity of the device change, and this is measured in the form of currents. You can see there is a change in current before and after. So there is a change. So that change is because of sensing. So it is used as a sensor, and because there is a lack of gallium nitride substrate availability, so people have done silicon substrate. Substrate nothing doing. Substrate is just only a a place where you will make the device. Just like we make some important thing, but some place is there, so that place is substrate. So substrate has no such role. Sometimes glass is also made as substrate. So silicon substrate is used, okay, and it has, although lattice mismatch is there, but we have no other option because gallium nitride wafers are expensive and not easily available, whereas silicon wafers are very easily available. So silicon wafers are used for making the device also. And this is also another type of sensor, GaN heterostructure field effect. I said this is field effect transistor, okay, and we are doing the heterojunction heterostructure. So the sensing mechanism have been done. Okay, so and it is measured using the change in current, change in transconductance. So this is a floating gold sensing gate, biochemically modified GaN high electron mobility transistor. Okay, so this is the two-dimensional electron gas form, and the formation of the two-dimensional electron gas, okay, sensing the biomolecules who are interacting with the device in the form of a gate material. So it is making the sensing, and from that sensing we are making lot of sensing activities. Okay, so this is one metal gated GaN HEM, okay, and extended gate GaN high electron mobility transistor. Okay, so this is the same device. This is micrograph. It is already fabricated. Okay, and the change in the sensitivity and the current that we can observe, and sensor device can be realized using this. So this is some modeling work, dielectric modulated. So here the dielectric, you are changing the dielectric, okay, by putting some of the biomolecules so that the dielectrics have been changed. Okay, and the changes are observed in the form of current, okay, in the form of two-dimensional electron gas, okay, and in the form of output characteristics in the form of GM, transconductance. So these are some of the literature. Okay, so I'm just giving some of the biosensors, and finally I'm going to conclude, okay, that this material is actually has a lot of potential. It is used in optoelectronics, it is used in power electronics. Nowadays people are focused in sensor for biomedical applications. Okay, and this is not very big work. Okay, our undergraduate students, they are also, if they keep interest, they can also do this because simulation work, modeling work, so they can also do it. So BTech, very good BTech projects can be done with this. Okay, and nowadays lot of softwares available. There are free version softwares available, so people can do this type of research. And nowadays technology of sensor technologies everywhere, sensors are there, starting from healthcare, okay, and amusement, entertainment, everywhere sensors useful are there. Every instant we are taking photographs, okay, and whenever you are taking graphs, lot of sensors activated, and they are actually visible in our camera, so that that sensors can also be done using this device. So integration with IoT means connection and communication. You can use 5G, 6G technologies, communication also, okay, so that you can transfer your signals from one place to the other place. So wearable biosensor, AI-based diagnosis, you can take the help of artificial intelligence to gain lot of knowledge in short time. Okay, lot of literature you can do. Okay, lot of investigation you can do using AI-based diagnosis, and opens pathways for personalized medicines. So lot of thrust is there, lot of potential is there. So this GaN high electron mobility transistor sensors combined with selectivity with exceptional resilience, making them a promising platform for next generation biomedical diagnosis. So our healthcare can be improved, okay, and so that it is a direct contribution to the societies. Now our research, our scientific contributions, so that society will benefit out of our research. So this is my research group. This is last visit I had visited to United States NGIT. So this is the collaborator. Now he is in Texas State. So I had visited also here. So this is our students, the United States students. And my acknowledgements, direct acknowledgement, because these students, they have done with me on this device. Starting from 2016, my first PhD student, and now is going to be awarded in 2026 on sensor. So all this is research. This is the sensor based the student is doing. And thank you all for your presence. If you have any doubts, any questions, okay, you can catch me here, or you can ask me also here, sir. Sir, the softwares are Synopsys TCAD. The software is Silvaco TCAD. These are two actually very renowned softwares. They are actually for long they are dominating the entire globe. But very recent time, Agenda and some other TCAD softwares they have come up. But I will always prefer to go for Synopsys and Silvaco. Synopsys TCAD software is focused for silicon-based devices, and Silvaco TCAD is best for compound semiconductor devices.
Throw some light on the power products devices.
Yes.
So these SIC and gallium arsenide. So vis-a-vis these silicon-based devices, what is the advantage of using them?
Sir, silicon, first of all, its band gap is less, so that it cannot sustain for large temperature. So whenever we increase the temperature and the device are used in nearer to any turbine, nearer to any in space where actually huge temperature is there, silicon cannot sustain. Silicon will melt down, the device will rupture inside, electromagnetism will occur. So silicon-based MOSFETs are not at all useful for power electronics.
Can we foresee some of the applications related to daily charging system?
Yes, sir. So few years back, silicon carbide came. Whenever gallium nitride was not come into the picture, silicon carbide, silicon and carbon mixed, they made a wide bandgap semiconductor. Power electronics done using silicon carbide long back, 20 years back.
That's it. So your exposure and your work is really very amazing. And a lot of potential there. Thank you very much.
Thank you, sir. Nowadays, our government has initiated on silicon carbide, which was obsolete 20 years back. Nowadays, in Odisha, silicon carbide, one factory, one company has come out. Silicon carbide, they have focused. But now we have reached to gallium nitride. So gallium nitride is thrust areas. Everywhere nowadays looking for gallium nitride integrated circuit. We had heard silicon integrated circuit, but nowadays we are working gallium nitride integrated circuit.
Thank you, Dr. Nikka, for your very nice presentation. You have started with the basics of GaN devices. You mentioned some of the applications in the field of power electronics, but you elaborated details on sensor applications. Just regarding issues in respect to power electronics, we are working in the field of power electronics. In silicon devices, we are working up to 100 kilowatts for developing the power manufacturers. And just I'll be coming to my point. In Calcutta, the Tego Technologies, which has been taken over by Global Foundries, they are developing the GaN devices. And some of my students are also working there. But we are mentioning two important issues. First, why the gate driver circuits or the GaN MOSFETs are to be integrated with the devices. For silicon devices, we develop the gate driver circuit separately, then we connect it in the PCB itself, but for the GaN, it needs to be integrated. Otherwise, there are chances of failing. So, can you suggest how to work on these issues?
So, first of all, gallium nitride IC, your cooling is not required. Whereas in silicon type devices, extra cooling supply is required. Cooling means fan, okay, it has to be there. But gallium nitride, cooling is not required. So, that is one of the advantages. And gallium nitride, as I mentioned, nowadays it is made on silicon substrate. silicon carbide based substrate also, because gallium nitride wafers are not that much available. Okay, and exactly to your point, I have to again, we have to discuss with that, so I can think of.
One more question. Another point. You mentioned what about the intrinsic body capacity, drain source capacities of GaN devices in comparison to silicon?
Yeah, capacitance is very less, very less, so that it is actually used in gigahertz range. Starting is gigahertz. So one of my PhD students, last G. Purnachandra Rao, you see he has demonstrated theoretically in terahertz.
High power applications?
Yes, terahertz application. In our research publications, we had mentioned 1000 gigahertz the frequency. So that he has obtained from his structure.
That might be in signal applications. In high power, in terahertz.
And high power means we are focusing on the how much voltage it can sustain, how much voltage, how much power it can deliver. We are telling in terms of that it is a high power device. Okay, thank you.
Thank you, sir, for your insightful talk. So I have a small question. The 2D materials that we are using in our device, any device, so how much it can feasible for fabrication and all these things?
No, you can introduce 2D materials in the channel also.
Yeah,
In the channel, yes, you can channel that. Okay, so you can do that. And lot of 2D materials based high electron mobile transistor are also people are working on it. But I have never worked. Okay, so 2D materials are very upcoming, very thrust areas. We can introduce with this device.
And sir, one more thing, when we are introducing circuits by using these devices, we are getting very lower frequency. For high frequency application, suppose operating frequency for an oscillator, but we are getting near around 2.5 Hz, 2 GHz for 20 nanometer channel. So that is that may be the drawback. Or
no, you cannot tell like this because many parameters. It is also what type of circuit you have taken. But device itself, it gives you a frequency of, let's say, terahertz.
Okay.
And in circuit you can expect at least gigahertz.
Gigahertz, yes sir. Gigahertz we are getting. Sir.
So we cannot conclude that it is giving less gigahertz, less frequency in circuit.
Compared to other PDKs, or if we consider like 3 nanometer.
Because it is still in research, people are not yet.
It is not established.
Mature technology. Yes.
Thank you, sir. Thank you very much.
Okay, thank you for listening. Okay.
Thank you, sir, for your wonderful keynote session. With this, we proceed to the next session. We are truly privileged to have our distinguished keynote speaker, Dr. Basuki Rahmatul Alam, sir, in online mode. The next session will be in online mode.
Okay. Yes, it's clear. Good afternoon, everyone. Okay, thank you very much for the introduction. It's very honor to me to give the keynote speech this afternoon at Acmesga 2026. Thank you, Professor Trupti, Rajan Pajanengka, and Professor Sadar, and the General Chair and Professor Imran Saka, for me to make this happen. Sorry, I cannot travel to Kolkata since the visa is quite is complicated to enter India. So I just give this online presentation. My talk is about the RF microwave wireless power transfer, WPT, based on the element Kalun method and Kalun method 10. I am Basuki Ramadhan from Polytechnic Degree Batam and also Microtronic Center of ITB. So the outline of the talks is why the RF wireless power transfer, RF WPT, elements of the RF WPT, RF WPT optimization, implementation and conclusion. Why the RF wireless power transfer, RF WPT? RF wireless power transfer is a power transfer technology. So sorry, I think it's using our electromagnetic fields radiation, enabling the transmission of the electromagnetic energy from the power source to a receiving device through RF EM mediums, where the received EM energy is then converted into the DC voltage and current. RF WPT is advantageous both in a remote area with limited infrastructure and absolute human resources, but the battery charging cannot be done. Cannot be done without the cable, and also in urban area where the convenience. Sorry to press. Yeah. In urban areas where the charging can be done instantly during the idle time or any time to replenish the battery energy. Now, let me show at this page that there's a method of the wireless power transfer through the electromagnetic field, but using the line coil. And so this need to be meticulously aligned to have the transfer is optimum. But the RF wireless power transfer, you need just to get in proximity, and if it is sit in a distance, it still can be transferred amount of the energy. Maybe you show it here. That is from the DC, this is from the signal AC source. So using that switch RF high power amplifier and through the transmitter antenna, and then transmitted to the receiver antenna, and it will be rectified using the RF to DC rectifier, and then to get the DC output. Then if we need to charge the battery, we can using the DC to DC converter to charge the for instance the lithium battery according to the constant voltage and constant current. The elements of the WPD is show that start from the power supply that bias the power amplifier, and then it will be transmitted to the transmitting antenna, and then will be receiving antenna, and then will be rectified to get the DC directly from the RF power, and then after that they rectified to get the DC output. And here you need to optimize from the RF high power amplifier. The efficiency should be over 80-90%, and then the transmitter antenna to have also the close to 80-90% efficiency, and then the receiving also at the same level, 80-90%, and then the rectifier, RF to DC rectifier should be set at the 80%, and then the rectifier set, and then total compression, just the best we can get is about 45%. But if we optimize here, it's not easy to optimize that. The RF power amplifier is to achieve the more than 80%. There's the class of the RF high power amplifier that better than the class EB. It is should be the switch RF amplifier from the class B, E, and F, etc. And also the antenna should be also the design quite well to get the efficiency to 80-90%. And then for the DC, RF to DC rectifier, that should have the high efficiency over the 80%. So we need to decide that the rectifier that's in this case I choose the inverted kit of fact RF high power amplifier to get to function as the rectifier. So, from the design, we may get the efficiency over the 80%. Okay, so we will show that what's the okay. First, we need to start with the large power transfer optimization from the high power amplifier. There's the amplifiers need to be designed to convert the DC power, and to transmit the RF signal at the highest efficiency, and we have to set the power edit efficiency to be over 80%. If we get a good class E RF high power amplifier, we may get over 90%, but it's not easy to decide that. This is the RF high power amplifier class E. It shows that at the transistor need to be switched in half wave signal, on and off. So we will get the voltage in the half wave, and then the rest, the remaining half wave, we get the voltage at the output, at the drain of the fat amplifier. So at the output, we put the tank resonator at the fixed frequency, so we get the sinusoidal signal, and then we will get the sinusoidal signal with since the current and the voltage is not at the same and the same period, so the dissipation will be at the lowest. The DC dissipation is at the lowest. So this is the ideal class E power amplifier. But in the reality, it's not the case. This is the method. I think I don't need to discuss this because we need to base the standard simulation from the load pooling, and then after that we lay out and the layout optimize the simulation and the harmonic balance and the electromagnetic field magnetic simulation using a finite element method, and then it's whole simulation and in turn it simulated to get the optimum performance based on the optimum load impedance. This is not from the DC IV characteristic. If we put the load line at the cutoff, and then at the highest, this is close to the saturation region. Yes. So we will get in switch, and then we will get the current signal and then the voltage signal at not at the same period. So we may push the transistor working at the highest power efficiency. This shows that the load pooling to get the optimum load impedance. We get the optimum load impedance, but it's not the best one. The power factors are the power. We get often the 54 dBm, so above the almost 200 watts, and then the power efficiency. It's not we can get to 80%, but we have ample power efficiency to close to the 70%. Is 7%. So we use that, and we run we simulate again, and we did the whole simulation. We get the gain at the I think start from the low input power. It's close to the 20 dB, but often the 50 dBms it drop to less than 10 dB, and then the efficiency is over 80%, but the quality efficiency get the highest at 42 dBm, but at 50 dBm it dropped to 60%, and the power output around is from the 250 watt to is from the 250 watts with the power input power of the 40 dBm, and to the 50 to the almost to 300 watts. And this shows that the current signal and then the voltage signal is quite working at the different periods. Yeah. But still there's the current and voltage still generate dissipation, because show at the same still flowing at this at some area. This is the layout of the high power amplifier, and then to did the simulation. We get the better voltage and current waveform, the best optimum one, and this the layout, and then this after implemented on the RF PCB, the dual RF PCB. Yeah. The footprint around 104 millimeter by 68.5 millimeter is quite big up. And we did the measurement, yeah. But there is a problem. We can have the output close to the 8 watts, but at the 4 input about 24 dBm. Sorry, it's close to the 40 dBm with the input power of the 24 dBm. That's around 60 dB gain. But that is not easy to get over 40 dBm because probably the radiation or the grounding loop, and so it hindered the measurement at the input power, at the output power of the 40 dBm. So we cannot get close at the expected output power of the 50 dBms over the close to the 200 watts. We need to correct it. So this is the show the efficiency close to the 20% at the highest output power, and the power efficiency also over 70%. That's good enough. So I think that I will the conclusion later. Then we will show the design and the implementation of the inverted gate on Kalimantan ham class F 300 watt. Is there two? Yeah, class F 300 watt high power amplifier. This is the design, and this shows the simulation of the high power amplifier using the Kalimantan FAT 300 watt. So the design we need to expect to have DC to RF power of the 300 watt at the frequency of 2.6 gigahertz with the lowest power rate, but the power efficiency that we achieve not good enough, not the highest we like to have is only less than 50%, and the efficiency also close to 50%, and the input power of the 45 dBm. Again, we get over 50 dBm with the input power of the around 35 dBm, and at the 45 it dropped to 10 dB, and output power over 20 over 50 dBm. So it's the design is showed it on more as covering the specification. And this is the layout of the high power converted gallium nitride FET around to DC rectifier at the frequency of 2.6 gigahertz. This shows that the input is used through the couple. It's sent back to the input using the phase shifter. I think it's shifted to 180 degree, and then going into that, and then the trade the DC voltage we acquire from the point that we used to put the trained by us. This is the layout. I think the footprint around 8 centimeter by 13 centimeter, small enough. This is the schematic. I think I did to reply. This is the result from the simulation. The output, DC output versus the input power. The rectifier efficiency over the CT5 almost 65%. Then the DC voltage over the 100 volt. And then they show the very interestingly that the 53 dBm input power, the DC output voltage jump into higher voltage from the 24 to the 60 volt and also to 100 volt, even at over the 55 dBm. I think it is over the 300 watts. And if you more the result, there's different jump light at the 53 dBm, push to the DC voltage even at 200 volt. And this as well at the PP3, and the output voltage is at the 100 volt from the 24. And this but from the measurement, we still, since we cannot do over the 40 dBms, and so we only show that the converting from the RF energy and RF power to the DC output, we get almost 2 volt. Close to the 40 dBm. At the time we were not able to do the measurement of 40 dBm because the problem the ground loop and probably also the radiation. From since we don't implement the Faraday cage for that, we will correct that later. Okay, and then this show the design array and microstrip array antenna. Because it is also important. We use this kind of array antenna only 2% very small because we put on the RF PCB. It's quite expensive PCB board. So we have to be conservative to use that. And this is the simulation of the RT or the parent element method that we get the reduced pattern here, the electromagnetic field, the EM field, and the frequency 2.6, and then the gain around 8.1, and the radiation efficiency almost 80%. It's quite good enough. But on the expensive Duroid PCB. And my student did the measurement that is show that the transmitting antenna and the receiving antenna, and do the correlation of how much power is received with the distance, and get the linear relation of the distance and to the power received from the transmitting antenna. That is the converting. And the conclusion that the analog HPA and SE with reasonable efficiency have been designed and implemented with the measurement result of 39 dBm for power input of 24 dBm. higher one output, more than 50 dBm, higher than 100 watt, you need to construct the isolated grounding loop and the stabilization toward the bias supply. After DC expired, there is a derivative kit vat of gallium nitride plus runoff vat has been designed and tested through the transmission antenna radiation received by microstrip antenna counterpart where the DC voltage over 1 watt has been acquired at 76 dBm RF. So if we can go over the 40 dBm, we may have maybe the jump at the 453 dBm to the 100 watt. But we need to prepare the setup and instrument setup with good grounding and with its resolution gates to prevent the electromagnetic radiation. Alat small transfer has been demonstrated. The set of radiation from the traditional and parallel gates need to be constructed. One higher power instrument according to maximum specification of HPA and inverted gate rectifier. Okay, thank you for the attention and for the chance to present this keynote speech. Very appreciate to have that. Thank you.
Thank you, sir, for your wonderful keynote session. Now it's
Thank you.
felicitate our keynote speaker, Dr. Basuki Abdul Alam, sir. I would like to request our principal, sir, to do the honor.
Okay, thank you. Thank you for the chance to give the keynote speech, and the certificate is very nice. Sorry not to be able to travel to Kolkata to present.
Looking forward, sir. Next time, definitely you will be here, sir.
Okay, thank you. Next time is better. Thank you very much, Professor, and also Dr. Suci Janenka. Okay. Thank you. Yeah, thank you. Okay. So I can leave? Okay.
Yes, sir.
Okay. Bye-bye. Bye-bye.
We'll send this to you in your mail ID also, sir.
Okay. Thank you. Bye-bye. Okay, thank you.
চট করে পাঠাও।
Now everyone please go for the lunch session, and after that all the paper presentation sessions will be there in 403, 404 and 407. Room number 403, 404, 407. Please go to your respected rooms. Thank you.
করছি না না শাট ডাউন করে দাও, পয়েন্টারটা নিয়ে নাও। ওপরে আছে, আর সামনে থেকে খুলে নাও।